Hello ladies and gentlemen, we're going to talk about functions and whether or not they're increasing, decreasing, and we'll also introduce the idea of boundedness. So this is pretty straightforward stuff. There's a couple little weird things that we'll talk about, but let me go through just kind of show you what we're doing here. When we say a function is increasing, what that means is it's going up. Now we read left to right in math class, so as I read left to right, this function is going up. That means for this interval it is increasing. Similarly, if as we read left to right the function is going down, then it's said to be decreasing. So it's not that big of a deal of an idea like, okay, it's going up or it's going down. That's all we're trying to say. It's increasing on an interval and it's decreasing on an interval. Now what's tricky about this is we're only going to describe these intervals using x values in interval notation. So let me show you what I mean. If I say where is this interval increasing, so you just look at it, where's it going up? It's going up right there, it's going up right there. Okay, so the way that we say that is we have to look at the x values. The interval is from 0 to, I think that's 25. So we'll say from 0 to 25 it is increasing. Now there's some different ways we can use this notation, but what we're going to say is we're always going to use brackets for these unless it's going to infinity. So from 0 to 25 it's increasing, and then from here to there it's also increasing, so that would be from 35 to 40 as well. So we'll say union 35 to 40. So that says that there's two intervals in which this function is increasing, from 0 to 25, so that interval, and then from 35 to 40, that interval. So that's where it's increasing. Where is it decreasing? Right there is the only place it's decreasing, so what are those x values? I can use my straight edge, 40 to 50. So on the interval 40 to 50, it is decreasing. And the last thing, the option B is like, well, what if it's constant? What if it's not increasing or decreasing? I think these might be increasing a tiny bit. It's kind of hard to tell. I almost think that might be increasing, but we're just going to say these are both constant. So that's constant. That looks pretty horizontal to me. And then that's constant. So what are those intervals? 25 to 35 and 50 to 80. So 25 to 35 are my x values, and then we'll say union 50 to 80 because there's multiple intervals in which this is constant, or if that's not constant it looks constant. It's pretty close. Okay, so that's increasing, decreasing. Let's maybe just do a couple more to make sure we kind of got it. Where is each of these functions increasing or decreasing? So we'll say, where is it increasing and where is it decreasing? We'll just screenshot this a little bit. Okay, boom. And we'll make another one. There you go. Awesome. Okay. So where are they increasing? Where are they decreasing? They are increasing where they're going up. So that's right there. Remember, we read left to right, just like in English class. So then you got to be careful. The x values is what you're looking at. The x values, it's increasing from 0 to 1. And then we're always, like I said, we're always going to use brackets. It's decreasing from there and there. So what are those x values? Let's see. This is 0, so negative 2 to 0. And then we'll say union 1 to 3. 1 to 3. So from negative 2 to 0, that's a decreasing interval, and then from 1 to 3, that's also a decreasing interval. So if you kind of look at it, you should say, well, there's three intervals here. There's 1, 2, 3. Just make sure you have three intervals. There's 1, 2, 3, 4, 5 intervals, so I need to have 5 of them. Which ones are increasing? Those two are increasing, so the x values are negative 2 to negative 1. Union, that's 1 to positive 2. 1 to 2. Those are intervals of increasing from negative 2 to negative 1 and from positive 1 to positive 2. Those are where it's going up. See, those are the x values where it's going up. Now I'm going to do the same thing with the y's, so it's decreasing there and there and there. So how do we say that? This is negative 3 to negative 2, negative 3 to negative 2, union, negative 1 to positive 1, union, and then that's 2 to 3. Okay, so there's 1, 2, 3, 4, 5 intervals. We counted 5 in the beginning. We've got them all accounted for. You just say, where is it going up? Those are the increasing intervals. Where is it going down? Those are the decreasing intervals. So nothing too fancy. One other thing we'll talk about right now is this idea of boundedness. So boundedness think of the word boundary and saying that there's a boundary or a border or any of these sort of ways that we describe the end of something. If a function is bounded below, that means that there's a border on the bottom. If something is bounded above, there's a border, there's a boundary on the top. It doesn't go past that boundary on the top. If it's bounded below, it doesn't go below a certain point. If it's bounded above, it doesn't go above a certain point. And if it's bounded on the top and bottom, then we just say it's bounded. You could say above and below, but we just say it's bounded. It's got a boundary above and below. So let me give you a picture of what these would look like. A function that is not bounded above, but is not bounded below. So that means it goes up and down forever in both directions. I'll just say something like that. It goes up, there's no boundary. It goes down, there's no boundaries. There's no boundedness here. One that is not bounded above, but is bounded below. If it's bounded below, that means there's a bottom to it. It has to turn around. There's a bottom. It doesn't go below a certain place. So I'll just say like a parabola. This is bounded below. It has a bottom to it, but it doesn't go below that boundary. So we say it's bounded below because there's a boundary. Let me get rid of that. This is not bounded above. It goes up forever, but it is bounded below. There's a bottom to it. Similarly, one that will be bounded above but not bounded below, I'm going to make it a little fancier. Let's say like that. Okay, there's a boundary at the top. It doesn't go above a certain point. There's a boundary on the top, but it does go down forever. So there's no boundedness below, but there is boundedness above. It's bounded above. And last thing, a function that is just bounded, that means there's a top and bottom to it. I think the most common one that we see in a pre-calc class is like a sine function. Let me see if I can draw that better. Like this. If you guys remember your sine curves, they go up and down forever, but they never... Maybe I should draw that with the tail so you can kind of make sure that you understand it's not going up. It's turning around. There you go. Okay? So it's going to keep doing that forever. That looks kind of like a cosine curve. It's got a boundary on the top. It's never going to go above. And it's got a boundary on the bottom that it's never going to go below. So we say that this function is bounded. So that's intervals of increasing and decreasing, and that's boundedness. What we're going to do next is talk about discontinuities. So we'll make that a different video though. So good job.